Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back. Now this question is again an extended version from your prime numbers, a specialized prime number. So in this case, the specialized prime number that we are requiring is Mersenne prime. So let's read the question first. A Mersenne prime is a prime number that is equal to 2 raised to the power n minus 1, where n is an integer, also a prime number. For example, 31 is a Mersenne prime since 31 is actually equal to 2 raised to the power 5, where 5 is an integer, which is a prime number, minus 1. So you are to write a computer program that finds all the Mersenne primes between 1 and 10,000. So the range of the prime numbers you have to determine Mersenne numbers from has changed. It is no longer 1 to 300 or 1 to 1000 in the previous instances. It's now 1 till 10,000. So first part that you're going to change. First, let's revise the name. This is now Mersenne prime number. So the first part, again, if you're unable to follow what I'm doing here, please watch out the earlier videos in which you will be clear as to what needs to be done here. So since we are to have all the Mersenne numbers all the way from 1 till 10,000, so one change that I'm going to incorporate here is that I'm going to enter or revise the value of the last element from 300 to 10,000. So after this, if I'm going to determine a vector p here, which essentially is a vector which contains all the prime numbers from 1 till 10,000, and when I'll run this program, you will get to see all the prime numbers starting from 2 all the way to 9,973, which is up to 10,000. So the first part of the program essentially remains the same, that is determining a vector p which contains all the elements between, in our case, between 1 and 10,000, which contains all the prime numbers. Now in the second part, we are going to make use of this p vector and we are going to make changes here as we did in the previous questions. So the question is saying that this time the Mersenne number will be following this trend or this equation which is 2 times 2's power 2 raised to the power n, where n is a prime number. So n will be taken from the vector p itself. So the only changes that we are going to make here, this will remain the same, this will remain the same. Obviously now the number of elements are different, so it's not going to be the same as before, but essentially the index variable capital N and the index variable capital M will remain the same. The only changes that you're going to make will be here in the conditional statement. So the conditional statements would be following this 2 raised to the power lower order element minus 1. So let's do it here. P and the higher order should be following, let me check, yes, 2 raised to the power lower order, which is mth element of p, minus 1. So if it follows this trend, then save it in a variable. Let's call that variable as Mersenne, and let's call out both the elements, both the mth element and the nth element. But which element will be the Mersenne number? This, the second column, will be the Mersenne number. And outside the loop, let's ask it to display the Mersenne number. So the rest has remained the same, only this equation, here it needs to be double equals to because we need to make use of the logical the relational operator here. So the relational operator, mind you, is double equal sign. So here essentially it has to be the lower order. Lower order is represented by the index variable m, higher order is represented by the index variable n. Now when you will run this program, you will get to see, so against 13, this is the Mersenne number. Against 7, this is the Mersenne number. Against 5, this is the Mersenne number. Against 2, this is the Mersenne number. Obviously it's not asking you to show this 13, 17, 5, the prime numbers in the prime numbers against which you will obtain your prime numbers. If so, you may omit it, asking that you don't want the mth variable or the mth element of p. So you may skip it or you may erase it. This way you will only get to display the Mersenne numbers itself. So 1, 2, 3, 4, 5. Only 5 numbers will be displayed. Only 5 numbers are there. all the way from 1 to the 10,000, which qualify as Mersenne numbers. So again, let me show you the program. This is the potential program that you will be making use of. Again, if you're unable to understand what is happening here, please check out the previous videos in order to fully understand what is happening here. Thank you.